A submarine is a specialized vessel designed to submerge and travel long distances underwater by controlling its buoyancy. Its ability to operate beneath the surface for extended periods makes it a crucial asset for national militaries around the world. But how does a submarine function while underwater? To understand how submarines operate, we need to examine their key components. As any object descends deeper underwater, the water pressure surrounding it increases significantly. Most human bodies and everyday objects are not designed to withstand such pressure, which is why submarines are constructed differently. Submarines are typically designed to operate at depths ranging from 100 meters to 600 meters, although some research submersibles can dive much deeper. Submarines have two hulls, an outer hull and an inner pressure hull, usually made of high-strength steel or special alloys, which allow them to withstand immense pressure. Another essential concept that explains how a submarine dives and surfaces is buoyancy. Simply put, buoyancy is the force that enables objects to float or rise in a fluid. It is determined by the difference between the weight of the object and the weight of the fluid it displaces. You might have noticed that fish, sharks, and dolphins have fins that help them swim and navigate underwater. Similarly, submarines have their own fins, known as diving planes or hydroplanes. When a submarine is submerged and moves forward, water flows rapidly over these diving planes, creating an upward force that helps the submarine maintain a certain depth. The angle of these planes can be adjusted, impacting this force and determining whether the submarine rises towards the surface or descends further. In other words, these diving planes help the submarine control its pitch to go up or down. Does that mean that any streamlined object with the same outer design and hydroplanes as a submarine can precisely dive and resurface the way a submarine does? Not really. Submarines are only capable of this thanks to a critical component of their design, the ballast tanks. These tanks are typically located inside the submarine's hull, and when filled with water, the submarine experiences negative buoyancy and dives underwater. Conversely, when the submarine wants to surface, it expels water from the ballast tanks and fills them with air, creating positive buoyancy that allows the submarine to rise towards the surface. The ballast tanks and hydroplanes work together to enable a submarine to surface or dive. Just as jet engines power airplanes and gasoline or diesel engines power automobiles, submarines require power for their motors and propellers. Most submarines are diesel-electric, meaning they have diesel engines that charge large batteries within the vessel. These batteries are charged using ambient air when the submarine is near the surface. Once the batteries are fully charged, the submarine can then safely dive and power its propellers and onboard systems. Since diesel-electric submarines need to stay close to the surface to charge their batteries, they become vulnerable to attacks from hostile military forces that are able to locate and target them. To counter this vulnerability, another variant of submarines, usually referred to as nuclear submarines, has been developed. These submarines are equipped with a nuclear reactor that powers their propellers and onboard systems, enabling them, in theory, to remain submerged indefinitely. The only limiting factor, in the case of a nuclear submarine, becomes the vessel's maintenance, as well as the crew's rations and other requirements. When a submarine is just below the surface, especially one with an older design, you might notice a metallic structure protruding from the water. This typically houses various controls and equipment, including the periscope, which allows the crew to visually assess their surroundings while the submarine is still below the water's surface. Modern nuclear submarines often have much smaller, streamlined structures atop their hulls called sails, which house communication equipment and sonar, among other vital pieces of equipment. In older submarines, this structure was commonly known as the conning tower. Additionally, submarines are equipped with sophisticated sonar systems that serve as their eyes and ears, as visibility is severely limited underwater. Sonar works by bouncing sound waves off objects, which helps determine their location and approximate distance from the submarine, aiding in detection and navigation. Since submarines are designed to operate beneath the surface, it is essential for the crew to have access to basic survival necessities, such as breathable oxygen and drinkable water. A submarine's life support systems generate breathable oxygen through chemical oxygen generators, which contain compounds like potassium superoxide. These generators, when activated, react with water to release oxygen. These systems also take care of removing excess carbon dioxide through scrubbers, which ensure that the air on board remains breathable. In case of emergencies, a process called electrolysis, which separates water into its constituents of hydrogen and oxygen, can also be used to produce breathable oxygen. Submarines can also create their own drinking water from seawater by desalinating it with the help of electricity. Submarines are one of the most fascinating marvels of technology, operating in one of the most awe-inspiring yet hostile environments on Earth, the dark depths of our seas and oceans. So, the next time you have the opportunity to sail aboard a cruise ship and gaze out across the vast expanse of the open sea, remember that there may be a submarine lurking below the waves, quietly performing its duties with dignified silence and infamous stealth.